Welcome to Study Loop.
Okay, so our question says that it wants us to try something at a sporting event, and it says show that the maximum height h attained by an object projected into the air, such as a baseball, football, or soccer ball, is approximately given by h is approximately 1.2 t squared meters, which I have written here, where t is the total time of flight for the object in seconds. Assume that the object returns to the same level as from that which it was launched, as in figure 42. For example, if your maximum height attained was h equals 1.2 times 10 to the fifth meters squared times 1.2 times 5 squared, it's equal to 30 meters. The beauty of this relation is that h can be determined without knowledge of the v naught or the angle theta naught. Okay, so in order to do this, I'm going to consider the downward vertical component of the motion, which will occur in half the total time. Okay, and then also and that's because the time it takes for it to go up and then back down is the time it takes for it to get to the very, very top at the very peak. And at the peak, the total time it is going to take for it to fall, or I'm sorry, the time it's going to take for it to fall back down from the peak is half of the total time, okay, which I can go ahead and write that here. So the time for it to fall down equals 1/2 the total time, which we'll call T sub capital T for total, okay? And then the equation that we're going to use is, well, y, this is equation 2-12b, y is equal to y naught, the initial y, plus v naught in the y direction, times time, because v is meters per second, we want it to be in meters, our solution in meters, so it's times time, times 1/2 the acceleration in the y direction, right, times t squared. Acceleration times t squared will give us meters, which is what the units we're looking for. Okay, and this is the total time. All right, well, let's go ahead and, oh, that's not the total time. That's just the time that we're considering in the generic equation. So now let's go ahead and plug in what we have for our situation. Well, what we're trying to figure out is h. Why not? Well, why not is what we're considering here to be the time it takes to fall from the peak. So our y naught here is going to be 0, right? Okay, we're going to consider that to be 0. V naught y, well, we're going to consider the velocity, initial velocity, to be 0. So that's going to be plus 0. And then this is going to be plus 1/2. A of y, well, we're dealing with gravity here, so that's going to be gravity. And then t squared, that we're going to be using the time it takes for it to fall downwards. So that's 1/2 the total time. Okay, so this is 1/2 the total time. Okay, and that is squared. All right, so now if we go ahead and continue on here, 1/2 squared is 1/4. 1/4 times 1/2, which is out front of the g, is 1/8. So this is 1/8. G is 9.8 meters per second squared, since it's acceleration, right? And then we have the total time here squared. Thus, this is approximately, if you take 9.8 and divide it by 8, that's approximately 1.2. And this is t squared. Units is meters. So therefore, box that in and we have proven the solution.